Dear students, welcome to today's class. The topic of the lecture is Principle of Superposition. Under this topic, we'll learn what is the principle of superposition and how we can apply this principle in solving problems. The statement of the principle is within elastic limit, as a result of application of a force, total deformation of the member will be equal to algebraic sum of the deformations of the individual sections, and this statement is known as principle of superposition. According to this principle, it is understood that suppose when a member is there, a bar is there having different cross sections and different forces acting at intermediate sections, then the deformation caused by each force is considered with its algebraic sum, and total deformation is calculated by calculating the sum. So to better understand this principle, we can mention that the total deformation is equal to plus minus P1 L1 by A1 E1 plus minus P2 L2 by A2 E2 plus minus P3 L3 by A3 E3 plus minus P4 L4 by A4 E4 plus minus P5 L5 by A5 E5. Here P1, P2, P3 etc. all the data is taken for each section 1 to 5 and so on. The plus sign represents the positive sign for tensile forces and the negative sign represents the compressive forces. So P is the force acting on each section, L is the length, A is the area of cross section, and E is the Young's modulus of velocity for each section. Now while such problem is taken, we make a free body diagram of the forces for each section. Suppose a bar of varying cross section is taken having three sections L1, L2 and L3, and each bar is having different diameter. The first L1 length is diameter D1, diameter D2 is for L2 length, and diameter D3 is for L3 length. So each section is isolated in the free body diagram, and the force acting upon each one is shown as L1 acted by P force on both its ends, L2 also acted by P force on both its ends, and L3 also acted by P force on both its ends. All are tensile forces because the overall bar is applied by a P force at both its ends. So each section will have the same force at both the ends. So this way, when we make a free body diagram, we can clarify the forces in each section and we can find out the deformation for that. Now to better understand this principle, we can take a numerical problem. Find change in length of a specimen shown in the figure. Consider its cross section as 500 mm square. Take E value 2 × 10⁵ Newton per millimeter square. Now the bar diagram is given. Having L1, L2, L3, the length is 140 mm, 200 mm and 260 mm. The forces are shown at each section, both ends as well as the intermediate ends. So we can see while making the free body diagram, for L1 section it is 240 kN pushing at the first left end, and a similar force is taken to balance this 240 in opposite direction. Now this 240 in opposite direction L1 is again balanced for L2 by applying 240 in its opposite direction. So the rightward direction will be there on L2. So the total force on the first end of the L2 is 240 plus 160, that is 400, and similarly the 400 is balancing it from its another end. Now the right end of the L2 section is having 400 leftward. Already in the given bar 600 kN is there in the leftward, so the net force 600 minus 400 will be acted upon by the third section in the leftward direction, so it is 200. Now balancing of this is 200 in the opposite direction. It is also given in the given problem. So this is a check that the given problem having the right end 200 kN in the rightward direction, this should be equal in the free body diagram also. So this way we can find out the free body diagram of each section. Now one by one we can find out the deformation. Suppose the first section, the deformation L1 is delta L1, P1 L1 by A1 E1. So the putting the values of the L1, that is 240 kN compressive force, 240 × 10⁻³ into the length 140 divided by 500 divided by 2 × 5, and this way we get 0.336 millimeter, minus means shortening as the force is compressive. Now for the second portion, the delta L2 deformation is P2 L2 by A2 E2. So P2 is here 400 kN compressive. So 400 × 3 into 200 the length divided by 500 the area of cross section into 2 into 10⁵ the E value, and this we get minus 0.8 millimeter shortening because of compressive force. Now the third portion, that is the delta L3 deformation P3 L3 by A3 E3. P3 is 200 kN tensile. So 200 × 10⁻³ into 260 the length divided by 500 the area and 2 into 10⁵ the E value. So we get 0.52 millimeter elongation because of the tensile force in the third section. So now we have three deformations now for each section. So by combining all these three, by using principle of superposition, you get total deformation delta L equal delta 1 plus delta L2 plus delta L3. The algebraic sum is minus 0.336 minus 0.8 plus 0.52. So this is minus 0.616 millimeter, and this is net shortening of the bar because of all the forces acting combinedly in this bar. So this is a case of the bar with uniform cross section but different forces at intermediate sections. So we have solved this one. Now another case we take in another problem, when the bar is having different cross sections and different forces also acting at different sections. So in this case, calculate the change in length of the specimen as shown in figure. Take E value 200 GPa, that is 2 into 5 Newton per millimeter square. Diameter for L1 is 20 millimeter. For L2 it is D2 32 millimeter, and for L3 it is D3 25 millimeter. So this bar is shown, every forces are shown in the L1 length 600 millimeter, L2 length 800 millimeter, and L3 length 600 millimeter. So the forces are shown in the 80 kN the first L1 portion leftward, and the another end of the L1 is 90 kN rightward. So at the right end of the L2 it is 50 kN rightward, and the last end of the L3 it is 60 kN leftward. So now we'll do a free diagram of each section. So for L1 it is 80 towards left, again it is balanced by towards right, so it is now a balanced section. Now in the first end of L2 it is 90 in the rightward direction, so here it is 80 rightward we have taken. So the difference of 90 minus 80, that is 10, will act on the first end of L2, and 10 again in the opposite direction will balance it. So it is 10 in the leftward direction. But in the first end of L3 it is 50 in the rightward direction, so the opposite direction, so we'll add this. So in the first end of L3 it is 50 plus 10, so that is 60 in the rightward direction, and the balancing opposite force 60 in the leftward direction. And this is a check that the last force of the L3 and the right end is equal to the force given in the problem also. So this is equal, it means our privilege diagram and the distribution of forces are correct. Now to calculate the deformation in the first section, that is delta L1 P1 L1 by A1 E1, and the first section is 80 tensile forces. So 80 into 3 into 600 the length, and divided by 3.14 into 20 square the diameter, divided by 4 pi d square of 4 multiplied by 2 into 5 the E value, and we get 0.764 mm, that is positive, it is a tensile force, so it is elongation. In the second section delta L2 P2 L2 by A2 E2, we have the force 10 kN compressive, so it is 10 into 10⁻³ into 800 the length, divided by pi 3.14 into 32 square, divided by 4 pi d square of 4 multiplied by E2 into 10⁵, and by calculation we get minus 0.049 millimeter. It is shortening because of the compressive force. Now for the third section delta L3 P3 L3 by A3 E3, so P3 is here 60 compressive, so 60 into 10⁻³ into 600 length, divided by pi d square by 4, that is 3.14 into 10⁵ square, that is 625, divided by 4 multiplied by 2 into 10⁵ the E value, and we get minus 0.338 millimeters shortening. And by combining all these three deformations using the principle of superposition, we get total deformation delta L equal to delta 1 plus delta L2 plus delta L3, that is algebraic sum taken 0.764 minus 0.049 minus 0.338, and this we get 0.377 millimeter. So finally the bar is under elongation having 0.377 millimeter. So this way we have discussed two different types of problems, one with the uniform cross section with different forces at intermediate sections, and another with the different cross sections and different forces at intermediate cross sections. So these are the two different type of problems in bars with varying diameter. This we have solved by using principle of superposition of forces. So with this, hope you have understood the concept. With this, thank you very much for patiently listening this lecture on principle of superposition. Thank you very much.